All right, so before we get to the review, this is a review for the test. Just a warm-up question quick with our normal distribution. So see if you can fill in the numbers and then find the percentages from there. It's based on fantasy football running backs for all you fantasy football fans. Okay, so if you had a chance to try it, but the mean is the number right in the middle. Sorry, I usually write them underneath, but I don't have space on this particular. And then we go up or down by 1.5. So that's my standard deviation. So go up 1.5, up 1.5, up 1.5. Going the other way, you just go down 1.5. So this would be 8.5, one standard deviation below. This would be 7, and this would be 5.5. So in our normal distribution, those are the values. And then what percent score at least 14 and a half? So that's right here, right? So at least that would be all the ones this way, right? All of these numbers are at least 14 and a half. So it would be everything except these ones. So honestly, I would do 100% minus 15 hundredths of a percent. So that would be like 99.85% score at least 14.5 points. What percent score between 7 and 10? So I would just add up those sections. So 7 to 10 would be here. Just add those two sections. So 13 and a half plus 34, that would be 47.5%. Okay, and you have to do something like that along those lines on the test. So chapter 11, there's a lot of topics. Okay, so I think individually they're not all that hard, but when you have to do them all together on one test, it gets difficult. So I think it's really critical to do these review lessons and make sure you do the assignment and stuff to make sure that you're ready. Okay, so here's the topics. If you ever want to pause and look at them, they'll also be out in the notes for today. Okay, so we're throwing a dart randomly, and we want to land it in the blue ring. Okay, and it's not drawn to scale. So some hints here, remember, area is pi r squared. Okay, and then I'm going to let you pause and try everything you can on this before continuing. Okay, so the trick is we're going to find the area of the whole thing. Like we're going to imagine that this was filled in, and then we're going to punch out this 10 pi radius circle on the inside. Okay, so the whole thing would have a radius of 11, and so that would be 11 squared times pi. That area would be 121 pi if it was filled in. Okay, but to get the donut ring, we have to subtract out the middle. Okay, and so we're going to punch that out. And so that's a circle with radius 10, right? So that middle circle, again, we're punching it out. That's radius 10. So that's going to be 10 squared times pi. So that's going to be 100 pi. Okay, so your blue ring then is the difference, 121 pi. Oh man, sorry, I cannot write this. 121 pi minus 100 pi. So that gives you 21 pi. Okay, and that's the area of the blue. So now to find the chances that we hit the blue, I just take the blue divided by the total, which would be this 11 radius ring. So that'd be 121 pi. Okay, and then the pi's cancel, and our chances is like 21 out of 121. And you could divide those to get a percentage, but I think that'd be about 1 in 6 chance if you reduced that or divided it, so about 17%. So if it randomly hits in there, chances of hitting in the blue ring is 17%. Okay, so percentile rank, remember, is the percent that you're ahead of or equal to. Okay, so these are scores in a basketball game, their average points per game, and we've got Sam here, and we want to find his percentile rank, and then a follow-up question of which value represents the 16.7 percentile. Okay, so 12 players. So percentile is the percent you're ahead of or equal to. So I could do all these or whatever, but basically Sam is ahead of or equal to 4 out of the 12 positions. So his percentile rank is 33%, about. All right, and so the 16.7 percentile, there's a couple ways to do this. You could just say 1 out of 16, is that the 16? You could divide it, but that's not the 16th percentile. Then you could try like 2 out of 16, and you would find that that is the 16.7 percentile. Okay, the other route would be you could take that percent, 16.7, multiply by 12 positions, and that will get you 2. Okay. Either way, the second spot is going to represent the 16.7 percentile, so that would be the 2.5 points. That's the 16.7 percentile. So on the test, it'll look just like that. Find the percentile rank by counting up from the bottom, that position divided by the total ones, and then the reverse is, I usually just do this, multiply the percent by the number of positions, and then find the value at that spot. All right, any bias here, what do you think? And the answer is yes, right? And so it has to do with strong words or loaded question, because it says excitement of rock and roll or the tediousness. Tedious means kind of like boringness of classical music. So this is bias towards rock and roll because of strong words. Or you could also say loaded. Sorry if I said leading before, but it should say loaded question with strong words. Okay, so I remember from past years, this ends up, these conditional probabilities and these and these two-way tables, these end up being the hardest thing on the test. Okay, so pause the video and give this a shot before watching the solution. All right, so the first thing I'm going to do is I'm going to fill in the total. So the male total, if I add all these together, I think is 100 males. Females, if you add those together, let's see, that would be a 3, I think 113, which means there's 213 total, which I guess they told us in the question. Basketball would be 94, soccer would be 97, and then volleyball here would be 22. And again, those should all add up to 213 if we did it correctly. Okay, so probability you're male, given that you played basketball. So it helps if you can read that, because it says given that you're in basketball, means I'm only looking at the basketball people, given that you're basketball. Okay, so my basketball people are right here. That's 94 of them. And out of those, I'm only looking at them. Out of those basketball people, how many are male? So out of these 94 basketball people, 54 are male. So the probability you're a male, given that you're a basketball player, is 54 out of 94. All right. Again, hopefully you tried this already, but play soccer, given that they're female. So now I'm looking at all the females, because it's given that you're female, so that's that column. That's 113. Sorry, I got covered up there. And then they play soccer, given that they're female. So out of those females, how many play soccer? That would be these 61. There's going to be 61 out of 113. Okay, so an and one, I think what gets tough here is students want to do the formula, but I think it does not work here because that's for like independent events, and so these are dependent events. So the better way is just to say, okay, female and volleyball, where are the female volleyball? Right, that's these 12 people. So that's the top number, and then there's no given that, so we're looking at everybody here. So the probability that an individual is female and plays volleyball is just 12 out of 213 total surveyed. So there, like I think on this test, I always tell kids you got to do what makes sense. Like, you can't necessarily always rely on the formulas. Just think about what makes sense and do it that way, which is definitely true here. Okay. So this is one involving mean. So I want to average 5 miles. So again, you can kind of do this guess and check as one route. Otherwise, you can set up with an equation, which I'll show in a second. But give this a shot before continuing. All right, so basically when you do a mean, you average the 6 days. So I have 3 miles plus 2 plus 4 plus 6 plus 3 plus X, because I don't know how many I have to run on that 6th day. Okay, so I want to add them all up, divide them by 6 days, and have that average come out to be 5. Okay, so that gives us a nice little equation for solving for the last day. Okay, so if I add all these up, let's see, that would be 10, 15, 18. So I think I have 18 miles so far. Okay, and then I'm going to take both sides times 6 to get rid of that divide 6. So I have 18 plus X. And so what this is really saying is if I want to average 5 miles for 6 days, I need to do 30 miles total. And since I've already run 18, I just subtract it off, and that means I need to run 12 miles on that last day. Okay, so another one that's kind of related to that two-way table. This is just with a tree diagram. Okay, and I think on the test you have to both draw the tree diagram and then answer these questions. So pause the video and see if you can get the tree, and then continue. Okay, so I'm gonna have to flip back and forth here because it's a little bit hard, but so 60% get Gatorade, and then all those that got Gatorade, some show growth, and then those that did not get Gatorade. So we're split based on Gatorade or not Gatorade. So the first thing is to realize like that's my initial split. So when I'm drawing my tree, I want to draw like those that got Gatorade and those that did not get Gatorade. So this is going to be up here, Gatorade and no Gatorade. And then I guess I should put Gatorade for that. And then after that, we're going to split them based on if they grew or did not grow. So out of the no Gatorade, did they grow or not grow? All right, so I'm going to label those. So we have Gatorade and non-Gatorade, and then grow, no grow, grow, no grow. All right, now let's just fill in the numbers. So Gatorade, 60% got Gatorade, and then that means 40% didn't. So my first label here, I'm going to label the Gatorade. I gave it to 60% of the plants. It means 40% did not get Gatorade. Okay, and then, whoops, wrong direction. Out of those that got Gatorade, 71% showed growth. So in the Gatorade one, 71% grew, which means 29% did not. Okay, and then out of those that did not get Gatorade, 58% did not show growth. Okay, so down here, 58% did not grow, which means 42% did grow. Okay, and so the next step before I answer all those questions is you want to do these and, right? And if you forgot how to do this, you just multiply down the branches, like 60% times 71, 60% times 29, 40 times 42, 40 times 58, and then that'll give you those four numbers. All right, so there's all our percentages, and that should add up to 100% because every plant has to fall into one of those categories. Okay, so now we have to do, I'm going to try to copy these over, see if I can fit them on that. Okay, so probability that they got Gatorade and do not have increased growth. Again, there's like a formula for and in this chapter, but like Gatorade, right, and not growth, that's just this path right here, right? So if we follow it down, that's just 17.4%. So don't make it harder than it needs to be. Okay, similarly, increased growth, right? These ones grew and these ones grew. So this answer is just 0.426 plus 0.168. And then the last one's probability they got Gatorade given that they showed increased growth. So when they say given that they showed increased growth, that means we only care about the ones that showed increased growth, which are again these two spots. So our denominator then is the same as the previous answer. Okay, and out of those ones that showed growth, which ones got Gatorade, right? And so that would be this number. So we'd have 0.426 out of the 0.594, right? And that would be the chance that they got Gatorade given that they showed growth. Okay, and that's a pretty tricky concept, but my hint would be the second part is always the denominator. So if I do the probability, say that they grew given that they got Gatorade, the bottom number becomes the Gatorade, right? So this says given that they got Gatorade, meaning we're only looking at these two numbers in our denominator. Those are the ones that got Gatorade. So our denominator would be those two values added together, and then our numerator would be one of those two numbers. So out of those Gatorade ones, which ones grew? So that would be this number. So it would look like that. 0.426 out of whatever those two things are added on the denominator. And that's a pretty tricky concept. So if you have any questions, as always, let me know. Thanks for watching.